This I will just we already started like more than 24 hours on this. I apologize for the technical difficulties yesterday that we could not do it. Uh, but basically, let me start with one of my earlier papers. When we were writing this paper, we noticed something about the environmental enforcement and compliance in India. And we looked at their data, and most of the companies, most of the firms on environmental regulation try to copy the behavior of complying companies. It's more like trying to avoid any serious inspection by the environmental regulatory. And then at that point, we came up with the idea with my co-authors and me developing a different game structure to analyze that kind of a behavior, which we call strategic compliance and inspection. Basically, let me move to my conclusion. This is not a mistake. I always like to start my presentations with my conclusion slide. Basically, what we expect in any kind of enforcement of regulations, especially in environmental area or in any area that the public policymakers are regulating, there are two different aspects. One is from the firm's perspective, there is a cost of compliance, and there is also an opportunity to get away with non-compliance. From the regulator's perspective, there is always a cost for inspection, and trying to catch the non-compliant firms or violators is always going to be costly. As a result, both parties in this game engage in strategic behavior. What we find in this paper through the experiment results is what is known as a confirmation of the Harrington paradox. That is, the public prosecutors or public policymakers, public regulators under inspect the violators, and the firms or the players on the other side of the regulation is over complying, not under complying, but over complying. The second result is whenever there is a possibility of hiding non-compliant behavior, firms immediately engage in that kind of a behavior. A third result is that that is relevant to more experimental design. Framing effects are significant, but the outcome, or when we put different labels to the same strategies, the outcomes might go in opposite directions. And finally, as a variation in the outcomes, we noticed overall compliance and inspection behavior starting at similar levels, both in the experiments in Kazakhstan and in Singapore. But after we introduced more complications into the game, they went into different directions. So basically, in the next 30 or 40 minutes, I will try to go more in details on how we reached these results. First of all, what do we talk when we say strategic inspection and compliance? As I briefly mentioned, we are talking about enforcement of regulations in a society. All of the papers in this area use Becker's crime and punishment model as the seminal paper, which uses a rational criminal and a rational enforcer. Here, actually, we talk about risk-neutral firms. They just look at the expected value of compliance and expected value of non-compliant behavior. That is, that includes the probability of getting caught and the probability of being prosecuted and the probability of a penalty after getting caught. Some firms can get away with it even after they are caught. Here, this model was later improved by Stigler's rational enforcement and the principle of marginal deterrence, which basically looks at the supply of offenses by the criminals or by the violators that has to marginally be equal to the expected benefit from the offense. And at the same time, rational enforcement is trying to minimize the damages of violations plus enforcement costs that would reduce possible violations. And in some cases, when the crime is not considered as a very serious offense by the society might have a desire to not enforce the laws to the maximum. The example Stigler gives in his paper is about the traffic violations. We don't see 100% enforcement, but only the serious violators are punished by the society or the public regulator. An important paper in this regard is the term non-inspectability, which discusses about the behavior by the firms of investing in more techniques to avoid possible inspection or getting caught. If that is cheaper than complying, firms actually might try to complicate the process. They will try to reduce the probability of getting caught and invest in non-inspectability instead of paying for compliance. Now, we are going to include, we included all these components in a typical inspection compliance scheme, which is usually considered as, this is from one of the recent papers, this is the strategic game between an environmental regulator and a firm. Here, the firm decides between complying and not complying, and the regulator, the agency, here, Environmental Protection Agency, decides whether to inspect or do not inspect. An interesting result, an interesting feature of this game is that there is no pure strategy Nash equilibrium, meaning that firm and the agency will mix their strategies by choosing different probabilities for inspection or for compliance. Now, if we look at the details of the model, here for the board, there is a cost of inspection, which we take as I. And when there is no inspection, there is going to be pollution or environmental damage. And in any kind of regulation, the thing that is unwanted, that is not desired to happen, is the internalized cost for the board or for the government or for the agency. From the firm's perspective, compliance is costly, and not complying is also costly due to the risk of inspection and paying a fine. Now, the probability of compliance in this mixed strategy Nash equilibrium is 1 minus I over F, and the probability of inspection is basically C over F. Basically, when the fines are going up, that means the probability of inspection goes down, or if you remember what C was the cost of compliance. When the cost of compliance goes up, the probability of inspection goes up. Similarly, when the cost of inspection goes up, the probability of compliance goes down. It is straightforward. And if the fine goes up, the probability of compliance also goes up. You can immediately see these results from these parameters. Now, here we add 2 actions to each player, one to the board's action, one to the firm's action, available actions. Here, the board decides between a tough or a full inspection or a cursory inspection or paper inspection. And as opposed to board's decision, firm also decides between full compliance or partial compliance by investing in uninspectability. Here, something interesting we found in the earlier paper is that most of the firms actually get the pollution control device, PCDs, in some plants, especially the overall ratio was more than 90% who bought this device, but only around 56% installed them. So what might be the reason behind buying the device but not using them is our explanation is they engage in some kind of strategic non-compliance, which actually extends the game from 2x2 inspection compliance game to a 3x3 game. The firm has three pure strategies. The first one is compliance, just buying and installing the device. The second one is strategic non-compliance, buying the device so that the likelihood of being inspected is going to be lower, but pure non-compliance is not even buying the device nor installing it. So the firm has three options. The board has also three pure strategies. One is full inspection that requires lots of resources. It is very costly, or a cursory inspection, sending some non-experts just to see around and then look if the firm is engaging in any kind of violation, if it can be caught by just a rudimentary cursory inspection, or non-inspection. The first one, okay, I think there's a typo. The first one is going to be no inspection. So the firm decides between no inspection, cursory inspection, and thorough inspection. Here, we actually looked at we actually defined the probability of a fine is 1 if the firm is not complying at all and the board sends a thorough full inspection. So there is no way that it cannot be caught because the board spends lots of money and that sends all the experts. And if firm complies, and the probability of fine is also 0. The important probabilities here are P and Q when the firm engages in different types of non-compliance. If firm engages in strategic non-compliance and the board sends a tough, thorough inspection, P is going to be higher than Q. Q is when the firm does not comply, but the board does not send serious inspectors, but only cursory inspectors to the plant. Here, again, C is the cost of compliance for the firm. N is the cost of non-inspectability investments for the firm, which has to be smaller than the cost of compliance because otherwise it doesn't make sense. E is the environmental cost or damage that is internalized by the board. Here, the cost of cursory and thorough inspections are T and I. Of course, the thorough inspection is much more costlier than cursory inspection. And F is the fine penalty for violation whenever the firm is caught in violation. All these parameters are positive. Here, the game becomes compliance, strategic non-compliance, or pure non-compliance. And then the board decides between thorough inspection, cursory inspection, and no inspection. Here, basically, these payoffs are just calculated what might happen. And here we see the probabilities. Both P actually plays a role when the firm is strategically non-complying or trying to hide its non-compliant behavior, and the board sends a thorough inspector. So it is possible to catch them. But if the board catches just on paper inspectors, they cannot catch the firm in case of strategic non-compliance. If the firm does not comply at all, then it is easier to catch it by looking at the probability of fine. The probability of fine is actually positive even through cursory inspection. If the board sends a thorough investigator, the probability of find is equal to 1. Now, if we put this game in a 3x3 game matrix and engage in the 3 strategies for each player, then we can calculate the probabilities of each strategy in a mixed strategy Nash equilibrium. But in order to do that, first we need to ensure that all of these strategies make sense from the perspective of that player. In order to do that, we first look at the rationalizability. The condition for rationalizability for each strategy is that these probabilities are non-zero and they are higher than these ratios. I will talk more about what these ratios are and how they affect these the outcomes. But whenever the probability of P and probability of Q are larger than these ratios, then all strategies become rationalizable. So whenever you see here, whenever the board does not inspect, the pure non-compliance is the best response. And whenever the board decides to send a cursory on paper inspection, then since N is going to be smaller than C, then strategic non-compliance is the best response. And whenever the board decides a tough inspector, a thorough inspector, then compliance is the best response, because minus C is going to be less than minus N and minus C is going to be larger than minus N and minus F. Similarly, for the board, it is the best response to not inspect when the firm complies. And it is also best respect to send thorough inspection when the firm sends a strategic non-compliance. When the firm does not comply at all, the board might be undecided between a cursory inspection or a thorough inspection. So that depends on the cost of inspection, as we differentiate between T and I here. In order to find that, we'll skip the proofs just to save some time. When the cost of thorough inspection is sufficiently large and the cost of non-inspectability is sufficiently small, then the game has no pure strategy Nash equilibria. And in other ways, we find that there are 2 pure strategy Nash equilibria, that is strategic non-compliance and thorough inspection, or pure non-compliance and cursory inspection. These will be the pure strategy Nash equilibria. The reason why we need these ranges is because when we design our experiments, we were careful in assigning these probabilities outside of these intervals, so that we will find a mixed strategy Nash equilibrium. Our result from the mixed strategy Nash equilibrium is about the probability of each strategy being chosen. Here, the inspection, the cost of inspection affects which type of non-compliance behavior the firm is going to choose, as it is obvious here. T is on the T affects the probability. Excuse me, sorry. T affects here the probability of strategic non-compliance, and the cost of thorough inspection affects the probability of pure non-compliance. Similarly, the cost of inspection and non-inspectability affects the probabilities of thorough and cursory inspections. Now, the probability of compliance in the 3x3 game then is different from the probability of compliance in a 2x2 game, which also is true for the probability of inspection. This is the probability of total inspection, that is thorough and cursory inspection. Here, if we just focus on the probability of thorough inspection, it is the difference between the cost of compliance and non-inspectability divided by the probability of the fine. Now, what does this model or these findings imply? First of all, higher fines, if we increase the penalty, lead to more compliance and less inspections. So the firm is inclined to comply more often, and the board actually conducts less inspections. When the cost of inspection increases, the firm will invest more in non-inspectability, that is strategic non-compliance. When the cost of non-inspectability, when the cursory inspection, the probability of detection actually increases the non-inspectability investments by the firm. Here again, if we look at this ratio has some interesting implications. That is, the likelihood of compliance is increasing in T. T was the cost of thorough inspection, unambiguously decreasing in I, that is cost of cursory inspection, and unambiguously decreasing in Q, that is the likelihood of getting caught under an on-paper inspection. Ambiguous in P, that is when the board sends serious experts for a thorough inspection, then the likelihood of compliance can go either way, depending on the non-inspectability or the effective non-inspectability. When Q is larger than this ratio of I over T, that is the cost of the ratio of different costs of inspection, then it is increasing in P. But otherwise, when the probability of detection under cursory inspection is sufficiently low, the likelihood of compliance also decreases, which is also straightforward. When cursory inspection does not catch anything at all, then the firm engages in more non-compliant behavior. The likelihood of a thorough inspection by the board is increasing in cost of compliance. When the cost of compliance goes up, firms are more likely to not comply. That increases the probability of a thorough inspection in the hope to catch these violators and collect fines from these. And it is decreasing in non-inspectable investments, which is also straightforward, and also in P, if the P goes up, the board actually can get the fines in less frequent inspections. The likelihood of a cursory inspection is decreasing in the cost of compliance and increasing in N and also in P. Here, because whenever the firm engages in non-inspectability or on-paper compliance, even cursory inspection is going to be sufficient to catch the firm whenever the firm is violating. So in our, how much time do I have? Oh, okay. We conducted 5 sessions of lab X1s with a total of 80 participants. That was 10, 14, and 24 in Singapore, 16 plus 16 in Kazakhstan. We also planned for experimental sessions in India, but unfortunately, due to COVID, we could not travel, and then we could not conduct those experiments. All players started with 60 points, and we set the payoff so that we set the payoff structure by assigning the cost of compliance, the fine, the environmental damage is equal to the fine, the cost of thorough inspection, the cost of cursory inspection, and non-inspectability investments. We chose these numbers so that the game is simple enough for the experimental subjects to play the game, and also simple enough to give us the data for evaluating the frequency of the mixed Nash equilibrium. Whenever we plug these numbers in, here in a 2x2 game, the game becomes a typical inspection compliance game where there is no pure strategy Nash equilibrium, and each strategy is a best response to a different strategy. Whenever we plug these numbers in the 3x3 game, we also chose these probabilities which is simple enough, but also within the interval that we calculated before, so that the game becomes a 3-by-3 game. In each corner, you see the previous game actually, and the middle row and the middle column are the extended version of the game. Here, whenever the players choose middle and left, then the probability of 50 and minus 30 happening is 10%, and probability of 0 and 20 is happening is 90%. If you look at the expected value of the payoff for the player A, it is actually 5, which is not larger than 20 or 10. And expected payoff for player B is 15, which makes it as a best response to player A's chosen strategy of middle. Similarly, if you look at the expected value of 60 and 10 happening with equal probability, that is 30 and 5. 35 is less than 50. Here you look at the 50% of 0 and 50% of 50. That is 25. That is the best response to player A's down. Here, something we tried in this experiment is we actually changed these labels. We asked the randomly paired subject, we randomly paired them and then asked the subjects to play 2 different versions of each game. First, by putting like neutral values to these strategies. In the beginning of the game, it served us 2 things. First, they familiarized themselves with the payoff structure, and there was a learning curve about the game. Second, the left and right and up and down were sufficiently neutral that they just focused on the probability of their gains. Something interesting we see in the results when actually we replaced these strategies with inspection and compliance, their behavior changed, although their payoffs remained identical. So we asked them to play 2 versions of each game. That is in total 4 different versions of the game for 35 rounds. We looked at the first 15 rounds as their learning period, and then looked at their later 20 rounds. And they in total played 140 rounds in approximately 2 hours. And their payment depended on how much money, what amount they collected during the game. Now, one of the things we noticed, actually, I will start here. Here, although game 2 and game 4 are identical, here I'm just giving you an example of how the behavior has changed. In game 2, the labels are neutral. In game 4, the labels actually we put compliance and non-compliance. Whenever we change the labels, overall compliance behavior has increased in Singapore, as you can see immediately from this. And in compliance behavior between game 3 and game 4, that is when game 3 is the 2-by-2 game and game 4 is the 4-by-4 game, 3-by-3 game, that is the extended version of the game. The compliance behavior seems almost identical in the 2 versions of the game, which needs more detailed look. And when we look at the detail here, especially in the overall picture, this is overall here. Whenever we put comply or not comply, the compliance behavior is around 40% in the overall game. It is volatile across rounds of the game, but whenever we distinguish between full compliance and partial compliance, that is, we can actually ignore partial compliance because that is not genuine compliance, that is just faking it. So the full compliance and non-compliance are different in terms of the game structure. The strategic non-compliance actually increases in the compliance game. This similar is true for the inspection behavior of the players. Now, if you look at a more detailed, check comparison, here game 1 and game 2 are without labels, and game 3 and game 4 are with labels. Game 1 and game 3 are identical, and game 2 and game 4 are identical. Here, the model predicts actually the compliance behavior to be around 20% or 15%. What we see here is overall, the players actually comply at 39%. That is more than double of what the model predicts. Model predicts around 20%, and overall, our subjects complied 39%. And if you look at the details of that compliance behavior is higher in Singapore. That is 44%, almost close to 50%, almost half and half people comply. And whenever we move from first game to the second game, actually, we also confirm our theoretical prediction that the compliance behavior should go down from 20% to 16%. But since there is over-compliance, overall compliance goes down from 39% to 24%. And Singapore compliance goes from 44% to 25%. And in Kazakhstan, the subjects actually, the compliance goes down from 32% to 22%. So it gets closer to what the model predicts. Now, in comparison between game 1 and game 3, what we see here is when we add the label, to basic up and down and left and right, compliance behavior immediately goes up. Although the payoff structure is identical, that is from 39 to 44% and 44 to 50%. So whenever we put anything that has non-neutral value, like compliance to a regulation, people are inclined to immediately change their behavior. We see the similar thing between game 2 and game 4. That is, although the model prediction is at 16%, we immediately see is like overall compliance goes up from 24% to 33%. That's almost 50% increase. In Singapore, it is much more. In Kazakhstan, as you see, it is from 22% to 24%. It's not that significant. Here, in inspection. Now, according to our parameters, we should expect 80% inspection without labels and with labels in game 1 and game 3. And that's probability goes down to 2 or 3 for thorough inspection and to 26% or 27% for cursory inspection. Here, what you see here is cursory inspection is almost as identical to what the model predicts. That is the inspector's behavior for sending out the cheaper inspection, if we translate it into the policy framework, is almost in line with what the model predicts. That is, that we don't see in anywhere else in our model. Here, the under inspection still continues in thorough inspections and full inspections in game 1, game 2, and game 3. Here again, the inspection behavior is almost identical in Singapore and Kazakhstan, but the compliance behavior is, we don't see that similarity in compliance behavior. That's one of the most interesting results, although they start around the same level of inspection, the compliance behavior is very different. Now, with my final notes about the compliance and partial compliance and inspection on paper inspection, one of the things we control for full compliance is about the how the current round of the game affects the player's behavior. We did not see that except in partial compliance. In partial compliance, they actually start avoiding partial compliance as the rounds moved forward, because it is 50-50% chance in partial. It is 90% chance of getting caught under a thorough inspection, which is a little bit higher, which results in less likely to engage in partial compliance or non-inspectability over time. Here, age is again a negative factor for partial compliance, but not significant for full compliance or on-paper inspection. What we see here, full compliance and full inspection, is gender sensitive, but in the opposite direction. That means when women actually comply more and inspect less. That is what the lab results say. We looked at whether they have taken game theory class before, which is very significant, which is not surprising to find. And if they actually like risk, that reduces their likelihood to comply fully. And here, as you see in the Kazakh citizen variable, it does not affect compliance behavior when you control for the other variable, but it affects the inspection behavior. So with these results, I would like to conclude that the confirmation of the Harrington paradox, people in the lab over-comply and under-inspect, and they engage in strategic compliance or strategic non-compliance, non-inspectability, just almost identical to what the model predicts, although all the other predictions are different from, all the other results of the experiments are different from the model predictions. Framing effects, that is, if you put the labels or remove the labels, they change their behavior, but it depends on whether it is an inspection behavior or compliance behavior. So people attach some normative values to those behavior. Overall, compliance and inspection behavior start at similar levels in Singapore and Kazakhstan experiments, but variations need further explanation, whether it's due to some more cultural values or some more fixed effects in regards to the chosen groups. I would like to thank you for your time, and now I would like to open the floor for questions.
Okay, thank you very much indeed, Omer. We've had a change of moderator during your talk, but it was most interesting and informative, particularly for non-economists. You delivered it in a very accessible way. So may I please open the floor for questions to Professor Baris? If you could raise your hand, that would be good to identify you, please. So I think Anna Chung has put some questions in the chat box.
I cannot see the chat.
Okay, so maybe Anna, if you could speak to those questions, please.
Thank you very much for the presentation. I just had a couple of questions on the model. Like, first of all, I wasn't sure whether this was multi-period or single period, because I would assume that if it's multi-period, then non-compliance should change the probability of inspection. That means the board is more likely to inspect those firms that were not compliant, for example. And then the second, yeah.
Let me answer that before your second question. Here, the game design is for one shot. And in order to control for that, we actually switched the pairs in each round. So they knew that. We also told them that you were not playing against the same player. It is going to be randomized in each round. So it actually controls for that kind of behavior, but we still see the some kind of behavioral change when there are some examples. One is like choosing one strategy and playing the same strategy for the entire game, for the entire round of game, whether it is, I mean, sticking to one strategy. It is one of the repeated game strategies, actually. The other is like whenever they are caught, they switch their behavior to that. So, but that is already built in the probabilities that we assign. So it should, because of the randomization in each period, that should not make too much effect on the results.
And the second question is for inspection, shouldn't the cost be risk adjusted? Because if you don't inspect, then you don't lose for sure. But I mean,
yes,
you don't lose again.
I mean, if you
like,
don't inspect,
right.
inspect, actually, the board doesn't pay for anything for inspection. But then for the violation is a cost for the board. So it is adjusted for that.
So then wouldn't the risk averseness of individual player affect the perception of their cost?
Well, that is true. We actually, if we go at the results, the risk, I mean, here, of course, the risk aversion actually has no impact on inspection, but has impact on full compliance. That is, the higher the risk aversion, the more the full compliance is. Am I sharing my slides?
You are, yes, you are indeed.
Yes.
Yep.
As the here it's risk lover, as we put it in the regression. That is, as the risk aversion goes up, full compliance also goes up. That's double negative, making it positive. But it does not affect the inspection behavior by the subjects, if that answers your question.
Okay, thank you. That was it.
Thank you, Anna. Any other questions for Omer, please? Can I ask a quick question, Omer, while people are maybe getting the thoughts together? What about policy implications from your work in terms of regulatory authorities?
Well, one of the thing is, what we see here is, in general, the firms overcomply. That needs some explanation. Actually, there are a number of alternative explanations to the Harrington paradox. That is, that the firms has more than the regulatory penalties in mind when they engage in this kind of behavior. So one of the implications for policy is more about the fines or the penalty approach, rather than understanding what the likely cost of putting society's resources in these inspections and these kind of monitoring and enforcement costs, and what is the benefit of those, which is like further inspection is not going to increase the compliance that high because they are already over complying. And here the individual behavior is again under inspection. Of course, I'm now thinking about how we can check in the real world how the policy, how the regulators are deciding on the frequency of their inspections. One of the things we know is they inspect frequent violators, then instead of just randomizing their inspections through all firms. So that strategy is not built in the one-shot game that we included. So one of the things on the compliance part is we need to look at the compliance behavior more intelligently rather than just looking at the penalty and correction approach.
So may I just ask, sorry to abuse my position here, but may I just ask another couple of short questions, Omer, which is, what about the transfer of learning here to other public policy areas? So, I mean, you're specifically looking at the environment here. Do you think, is there any read across to other areas? And the second kind of methodological question I'm just interested in, because you're continuing to do some experiments in this area of behavioral economics. What did you learn from this that you might, that would be informative in terms of any future experiments that you're doing? Because I know you're doing some work currently in this.
Yes, I mean, one of the things I learned is doing experiments in Kazakhstan is much more difficult than doing experiments in Singapore. That's for sure. That's one of the things that I learned. But it is still widely, how do you call it? It's an area that requires more research into this. Actually, we looked, when we were looking at this, we originally had a plan to do it in India too. So it's going to allow us for cross-country comparison between a developed country, a developing country, and a Central Asian country. The other thing that is putting us in more questions when we find actually interesting results in regards to the overall compliance behavior separating from Singapore is how to explain this variation. As I put that here, this variation needs further explanation. We need to actually crystallize the questions in each aspect of the experimental setup. Maybe we need to conduct another round of experiments just to test for another implication here. Unfortunately, we don't have the opportunity to conduct the experiments on, repeat the experiments on a weekly basis. But once we learn about these results, then we conduct the new experiments in the new design, which I believe, if it's combined with more field experiments, that would give interesting results. What was your first question?
It was just about the read across of this policy area into some.
Well, that is one thing. Our starting point was about environment, but this is true for any kind of regulation and enforcement. Here, I go back to Stigler's original paper, he mentions about how traffic violations are not enforced at the 100% level, but instead the police is focused on the most frequent violators or the most costly violators or the overspeeders. That is maybe the rational way of enforcing, instead of like chasing all the acceptable level of non-compliance, let me say. You don't want to chase everyone who's crossing the street or jaywalking and everything just to make a full enforcement. That would not be rational, because the amount of cost that you're spending on this kind of full enforcement is going to be wasting society's resources, which could be spent on something else. So it is some kind of maybe, if you allow me, just turn a blind eye on small violations, but focus more on more serious violations that would actually save resources for the society. Maybe I can come up with. I think Maksad and Ahmed.
Okay, Ahmed, yeah, please go ahead, Ahmed.
All right, okay, thank you. Can you hear me?
We can.
Yes, I can hear you, Ahmed.
So great, Omer. So thanks for the presentation. I do have a question though. The regulators put those rules for some reason, and I suppose to comply with the rule should be the optimal one. So then what is really stopping regulators to increase these fines as much as possible, which is going to lead us to an equilibrium where everybody complies and there's no inspection at all. So there's no cost then, or is there any cost?
Well,
No inspection
here
at all.
the literature on this is mixed in the way that regulators are inclined to adjust their policies through increasing or reducing their fines, mostly increasing the fines in expectation for that the fines are going to be sufficiently persuasive for the criminals not to commit the crimes. But the criminals or criminal behavior or crimes are more sensitive to the probability of getting caught. So if I think it was Becker's 1981 paper, or if I'm mistaken, I don't know by heart, but that is, if you increase the fine and reduce the probability, the expected value is the same, but the risk aversion or the aversion of the criminals or the violators, let me say violators to the probability is more than their aversion to the penalty. I mean, if you increase the penalty to $1 million, $100 million, and if you reduce the probability near zero, they would not mind seeing more zeros in the penalty and still violating it if they know that the violation is not going to be prosecuted or caught. So the sensitivity of their sensitivity towards the total risk factor, that is penalties times the probability, is different from each perspective. The policymakers actually are more inclined to adjust their policies through the penalty instrument, because changing the penalty instrument is not that as costly as increasing the probability, because increasing the probability means, I don't know, on traffic, it means more cameras, more policemen, and I mean, in other criminal activities, it requires more monitoring activities, which is costlier than just increasing the fine by a decree or by a voting mechanism. I would just say that the difference from the criminal's perspective or violator's perspective and the regulator's perspective actually makes the difference between compliance and inspection as a continuous mixed strategy equilibrium game.
Yeah, okay, so I see your point. In some sense, for let's say small crimes, jaywalking or or traffic light violators, let's say, you're right. So it's a big thing. It's a big sort of society, and you can't really go after everybody. But for bigger, for bigger setups where I don't know, big factories or firms who has to comply with some kind of rules. So for those, I guess it's easy to sort of induce them to comply to some rule by just increasing the fine, because it's really easy to detect whether they are following the rule or not, right?
Well, when we were discussing this, and actually there is one aspect we did not include in the paper that we would like to see actually the result, and I don't think it is possible to see it through experimental result, but more real world data collection. That is, how do regulators choose which firms to go after? One of the immediate results is frequent violators, of course. But what about the firms that are big in size and have good political connections? Then it might be risky for the regulator to go after them, but instead making the headlines with finding a small violator is much rational strategy, instead of going after the big and putting your status or your position in trouble. And if you have uncertainty in regards to connections or the firm's political power or links to the political power. That is one of the things that we discussed when we were starting this, but it's completely a different area, and I'm not sure how to include that in an experimental setup. But that's a good way of looking at different aspects of the same question.
Okay,
Okay,
I think we have a question from Yerasil.
Yes, thank you. Thank you for the presentation. Can you hear me?
Yes, Yerasil.
Okay. So just to clarify, you mentioned that the players are like neutral. I mean, overcompliance, can it be explained by the nature of the players? So they are risky averse or risky neutral?
Well, the game, the literature assumes in inspection compliance game as the firms and the board as risk neutral because, as I already mentioned, the individual behavior might respond differently to different parameters of risk. That might be the probability of getting caught. That might be the what happens after you get caught. There is also another aspect that is relevant here, as there are actually in the US data, there was another paper that the violators are caught, but they get away with it without paying any fines. That is, what happens after you get caught is also an important parameter in the risk perception. But here in the lab, actually the risk parameter is different. That's why we try to ask their risk perception through a number of different survey questions. How do they consider their risk neutral, or they like to take risks, or how did they play the game? They randomized it, or I mean, we try to investigate that, but it is not for sure if those assumptions will hold for uniformly for everybody.
Okay, so I think we can take a last
thanks.
question from Maxat.
Yeah, thank you, Omer, for your presentation. You partly actually answered to my question. I was curious about the results and the data that shows this relationship between the compliance and the real world, especially in regard to the reaction to the petty violations and the serious violations from serious players in the market. I'm far from the game theory debates and discussions. I'm curious about your future research direction. I mean, talking about Kazakhstan and a local context, we have one interesting case of the moratoriums when government periodically declares moratoriums on the inspections in certain areas. Yeah, in hope to help local businesses to develop, be promoted, and be out of any top-down control from a government institutions. It's fine if it is in certain areas where we could monitor and we have already statistical data to show this relationship, like as you mentioned, the public traffic violations. But what about serious violations, like, for example, we have moratorium on certain businesses related to food inspections, food quality inspections. What will happen there? I mean, we could imply that they will comply with the rules, but once the moratorium are declared, you really never know. And I'm kind of curious what international experience show in this connection, and whether you're going to look at these more practical aspects of this question. Thank you.
Well, thank you for the question. That is one of the things that we would like to see in real world data, but due to the nature of the data, all records, whether it's serious crime, serious criminal activity, or just rudimentary, more tolerable violations, let me say, we only see one part of the picture. We don't see what is not being caught, as like the famous statistical lesson from the I don't exactly recall the name, but they were asking where to repair the airplanes in the Second World War. They looked at the airplanes and coming back from fight, and then they looked at where the damages on the airplanes. They did collect some data on, like this one is hit on the wing, this one is hit on the tail, this one is hit on this part of the body. And the main lesson there was actually you should not improve you should not use that statistical data to decide on the improvement, because you only see the surviving airplanes. The ones that are hit and fell down did not come back, and you don't know where they were hit. And here again, similar situation is true here. With either way, you send the inspections, they write tickets either on traffic or like food inspectors, etc., etc. You only see what is caught. You don't see what is not caught, and you don't see who is really getting away with their violations and whether they are committing big violations or small violations. That is completely opaque, and we cannot say anything about it. That is one problem. Of course, it would be interesting to collect this data, especially what kind of inspection do regulators engage in? Do they conduct really full inspections or on paper inspections? That is, which is cheaper and which also gives the sense of relieving from responsibility. That might also be a strategic game played by the regulators if they don't want to make too much noise, but at the same time they don't want to fail in their responsibility. But again, I mean, this is interesting area to work, but unfortunately without these kind of experiments, it's almost impossible to get the data from each side of the table. I mean, we will never get the data about violators that never caught or the inspections that never happened.
Okay, I think we have come to the end of our session, and I want to thank, on behalf of all the participants, Omer for a very stimulating talk, as I say, in a very accessible way. It's provided a good advertisement for his game theory elective, which is always popular. So thank you very much indeed.
My
Omer.
student must be here.
Good. So
Yes,
just
we
to
are
remind
here.
people that our next talk is on the 9th of November, when we're having a talk with two professors on growth models, growth regimes, and bureaucratic autonomy, Dr. Apindine and Dr. Koban, which is on the 9th of November. So thank you all for participating, and I wish you a good evening. Thank you, Omer.
Thank you, everybody.
Thank you, Omer. Bye-bye.
Bye.